This video will give a quick description of the different parts of the Embrio application. I'll be showing the full version. The free version will have some of these things missing. First, I'll quickly go over the areas of the interface before expanding on each one. On the top is the main menu bar. On the left is the control panel, which has 3 control tabs. Most of the screen is taken up by the editor window, where most of your work is done. In the bottom left is the Arduino connection control panel. Next to that in the middle is the Playback control panel, and on the right is a message display which shows you messages and errors. The first tab contains a tree view that lists the agents and functions in your project. The folder layout in this tree is only for organization. It doesn't have anything to do with how the agents are actually connected to each other. As with any development software, it's important to keep your project well organized with a good logical layout and descriptive names. Right-click on a folder or agent to get a pop-up menu which lets you create and delete agents, functions, and folders. Drag and drop items to move them around in the tree. An easy way to add an agent node to a node screen is to drag it from the project tree. The Profiler tab displays timing and resource information for your project. In the overview on top, it shows you how many agents are in your project and how many total nodes are in those agents. The next piece of information is very important. This is the maximum number of milliseconds needed to run your project per second on your target hardware. In reality, if a node's inputs do not change, it may not recalculate its output values, but this number is a worst-case scenario, assuming that all nodes calculate new values on every update. In this simple project, only 40 milliseconds per second are used, meaning that for every 1,000 milliseconds, the processor is waiting for 960 of those milliseconds, or 96% of the time. Keep an eye on this value and make sure that it stays well below 1,000. 2 sortable grids show information for all agents and nodes in the project. On the Agent tab, we can see how many nodes are in each agent, how many microseconds the agent takes to update, assuming all nodes calculate new values, and how many times per second the nodes in that agent update, and a total microseconds per second used for that agent. Note that the total for the project is in milliseconds, but for individual agents and nodes, the value is in microseconds. There are 1 million microseconds in a second, and 1,000 in a millisecond. The last column shows how many nodes in an agent have no timing data. On the Nodes tab, we are shown how many times each node is used in the project, how many microseconds each node takes to update, and how many total microseconds per second each node contributes to the project. This makes it easy to see which nodes are using up the most resources. A -1 value in this column means there is no timing data for the node on your target hardware. When anything in the project needs timing data, the clock icon in the connection panel becomes active. Clicking on it compiles and uploads a program that calculates timing data on your target hardware and sends the results back. When the timing is done, the connection program is re-uploaded. The next tab shows you the node definition tree. A node definition defines the interface for a node and the code that it executes, so it's easy to create your own nodes. How to make your own nodes is discussed more in another video. Definitions are available on 2 tabs. The first tab are nodes that are local to the current project, and the second tab shows nodes which are shared by all projects. You can drag a node definition from the tree onto a node screen editor to make an instance of that node type. The node screen editor is the biggest part of the screen, and also where you do most of your work. Use the right-click menu to select a node to add. The first submenu contains input and output nodes, which are nodes that have access to the pins on the Arduino. The second submenu contains nodes that have to do with logic and the flow of data. The third menu has math functions. The rest of the submenus mirror the structure of your project and are filled with the agents and functions defined in your project. You can add an agent to a node screen this way, or by dragging it from the project tree. Inputs are on the top left of a node, and outputs are on the bottom right. Nodes update their output values at a refresh rate specified per agent, which you set at the bottom right of the node screen. Connect nodes by clicking on an output and dragging it to an input of the same type. There are only 2 types of inputs and outputs, numbers and triggers. Numbers go from the range of 0 to 1, or sometimes -1 to 1, and an input trigger fires its update code when an attached output trigger fires. The Arduino communicator panel lets you interface with an Arduino connected to your computer with a serial cable. There are 2 drop-down boxes and 4 buttons. The drop-downs let you pick the Arduino model you're using and which port it is connected to. The first button opens a connection to the Arduino. The second button is active when the connection program needs to be refreshed, which happens when you change or add an input or output node. The third button compiles and uploads a final program which can run on the Arduino without a connection to your computer. The last button becomes active when there are nodes in your project that don't have timing data for the selected Arduino model. Clicking this button uploads a program that calculates the timing of the nodes and sends that data back to Embrio. In the bottom center of the screen is a playback control. All numeric inputs and outputs can display a graph to make it easier to understand what's going on. Still, because data is streaming in real time, it can be difficult to see exactly what's happening. The playback control lets you pause the live data feed and instead view the past data. You can drag the timeline to scrub through the past values, increment one frame at a time, or play back in full speed. Turn off playback mode to resume the real-time data updates. This concludes the overview of the interface. The following videos will teach you more about each component and how to program real-time embedded software using Embrio.